a week, so I should have more than enough time, and I already signed up for 2 sessions, so
Okay, so the first thing it says is to find two vectors u and v such that u is a scalar multiple of v, but u and v have different unit vectors. So we're just gonna pick two numbers. Let's just say u is 1 comma minus 3. Is this notation okay?
Mhm.
Okay, so we could say, well, let's say v is 2 times u. And that means it's 2 comma minus 6. Is that okay?
Yeah.
All right. So this 2 is what's called a scalar multiple of v. Okay. Now, to find the unit vectors, this is something that you have to find the magnitude of u. Have you seen that notation?
Uh-huh.
And that is 1 squared, because there's a 1 there, plus minus 3 squared because of that, and then you take a square root of that.
Okay.
So that becomes the square root of 10.
And you did the same thing for B?
Uh, we're not quite done. So to find the unit vector of u, you take these numbers and you divide it by this number.
Okay.
Let me give you a different example, because I didn't think far enough ahead on this. Let me give you a different example. Let's say it's 4 comma minus 3. So the magnitude of u is the square root of 4 squared plus minus 3 squared, which is 5. So the unit vector, its unit vector in the direction of u is squared, or I'm sorry, bracket, angle bracket 4 minus 3, but then you divide it by 5. So that becomes 4 fifths comma minus 3 fifths.
Mhm. Okay.
All right. Now, let's assume that v is 2 times u. So let's do that. So that becomes 8 comma minus 6, and the magnitude of v is the square root of 8 squared plus negative 6 squared, which equals 10. Okay, so now we're gonna find the unit vector in the direction of v. Your instructor might have a different way of denoting this, but it's 8 comma minus 6 divided by 10, which becomes 8 divided by 10 minus 6 divided by 10, which reduces to 4
4.
fifths and minus 3 fifths.
Okay.
This is the same as the other one. Do you see that? Like, they're exactly the same.
Uh-huh.
But this question, it says that they have to have different unit vectors.
Okay.
Okay, so that's a problem. Okay, now we're going to resolve that problem. I guess I have to point out that the only way they're different is if you choose a number that changes this in sign. So let's say we make this -2 instead.
Wait, so you're
Let's
just choosing these numbers? Like, wait, can you go up?
Yes, yes. Sorry, go ahead.
Uh, okay, so you just chose, like, 1 and 3, and you just chose 4 and -3 because
Yeah, yeah. I was just making these up.
but it should, like, no matter what numbers you choose, it will end up, like you'll end up getting the same thing?
Yes.
Okay.
If you if the scalar multiple is positive, you get the same unit vector.
Okay.
That's like a property. Um, so the point is, though, to get them to be different, you have to say, okay, well, let's make v minus 2 times u. So now it's angle bracket -8 comma positive 6. Okay. And then when you find the magnitude of v, oops, I don't need that. Magnitude of v is -8 squared plus 6 squared square rooted. That's 10. So the unit vector now is -8 comma 6 divided by 10. And that ends up being -8 over 10 comma 6 over 10, which reduces to -4 fifths comma 3 fifths. And the unit vector for u, it was 4 fifths comma minus 3 fifths.
Okay.
So the
So
only, oh god,
oh, sorry. Well, I was just gonna say if it didn't say different, you would really only have to solve for, like, the first one, and then it would be the same for the second one, right?
yes, yes.
Okay.
Okay, so let's just briefly talk about what a unit vector is. So let's just say your vector u is 3 comma 4. I'm choosing these numbers because they work out really nicely. 3, 4. Okay, so there it is. That's u. Okay. Your unit vector has a length of 1, has a magnitude of 1, but it's in the same direction. So it's like if there were 1, 2, 3, if there are five, if there's sort of 5 tick marks, because that's how big it is, the unit vector is this little piece right here, the one unit piece.
Mhm. Okay.
All right.
So
So
there's
the only other unit vector is the one that goes in the opposite direction. That's what we're trying. That's what this question's really asking, is that unit vectors. The only way they're different is if they go in opposite directions.
so the first part you found is the unit magnitude, and then the dividing by that is how you get the unit vector.
The unit vector is your vector divided by the magnitude of your vector.
Okay. Okay. Gotcha.
What is the range of possible values of a vector? Okay. So number 5 is, I guess it's, did you get questions like number 5 on your last exam where they're more
Oh,
conceptual?
let me look on.
Like
Oh
what?
wait,
Oops.
we got some that were like she did put a lot of conceptual ones. Like one of them was um should I pull it up? There are two types of asymptotes. How do you find them? And she wanted you to talk. I don't really know, but
Okay,
or
so
like
those are
what
like those are the questions like she asks, like she's wanting you to become the, or he wanting you to become the teacher, where you have to know it so well that you could explain it to someone
yeah.
else.
Discuss how periodic and sinusoidal functions are similar and different. Provide a sketch. What is a radian? Like those type of things. And then she had a few like word problems too.
Okay.
And then there was some matching, and then there was function analysis also.
Yeah, so this is kind of one of those questions like you might see. It says, what is the range of possible values of the magnitude of a vector? So if I give you a vector a comma b, the magnitude of the vector is the square root of a squared plus b squared. So the magnitude of the vector, it could literally be um, as big as it needs to be, because these numbers are unlimited in their size. But um, the other thing though to consider here is the vector has to have at least some size. So like a has to be greater than 0, b has to be greater than 0. So that means that v, the magnitude of v, has to be greater than 0 as well. But it could be as big as you want it to be. So the point is, like, a vector could be little or it could be big. We don't
So
we don't know.
if it was a like less than zero, b less than zero, the b would be also less than zero.
The but the okay, sorry, a that's this isn't quite right. A and b can be positive or negative, sorry.
Oh,
um but they can't be 0. Well, they could be 0, but they couldn't both be 0. So let me a comma b cannot equal 0, both be 0, because then it has no position.
right. Okay.
So they always and the magnitude is always the square of them, so the magnitude is always positive.
Okay.
Does that make, like it doesn't matter what a and b are, as long as one of them is positive, you have a vector, but, or
And
one
it's
of them is not 0, you have a vector. But
and it's always gonna be greater than it would never be
yeah,
zero.
can never be 0. It's always greater than 0.
Okay. Okay.
All right, I'd like to move on to 6.2, unless there's more things about 6.1 you would like to talk about. You should be able to do things like, I mean, these are the classic questions. Is like u equals 3 comma negative 2. V is negative 4 comma 5. And there's questions like, what is u minus v? What is u plus v? What is 2u minus 3v? What is 4v minus 2u? Are these questions you think you could answer?
Um, can we go over some of them?
Okay, sure. And I'm going through them quickly because they're it doesn't seem like it's being emphasized here,
Uh-huh.
uh, but maybe it is. So, like, let's say I want you to just do u plus v. So u plus v means 3 plus minus 4 comma minus 2 plus 5. You take the x components and then the y components and add them together.
Oh, yes, I remember this. Okay.
Okay. Now I
Oh,
can
this is the what's called dot product.
no, that's
Oh,
different. That's
oh.
different. And that's that. I mean, maybe this isn't covered because it's not in there. But you should be you generally are asked to add vectors. Okay. So now, like another question, I say, what is the magnitude of u minus v? Okay. So to find the magnitude, you first have to find the vector. So the first step here is to figure out what is u minus v. So u minus v is you take the first number 3 and you subtract -4, and then it's minus 2 minus 5. So your vector is 7 comma -7. That's u minus v. So to find the magnitude of that, it's 7 squared plus -7 squared square rooted. And this ends up equaling 7 square root 2. Do you think those are going to be on there?
I think there would probably be like one, but the square root, that's just like something that you do for every problem.
You have to do it for every problem when you're finding the magnitude.
Okay.
Okay, so then another thing that I might be asked here. Let me copy these vectors down again. Get rid of these lines. Is I could ask you to do a product. I'm sorry, not a product. A scalar multiple. So I could say what is 2u minus 3v. So 2u means multiply this number by 2. So that's 6 comma -4 minus 3 times each of these. So that's -12 comma 15.
Hmm.
So then when you subtract, it's 6 minus a minus 12 minus 4 minus 15. So that's 18 comma minus 19.
Okay.
So basically you add the x's, you add the y's. Have you talked about anything in 3 dimensions?
What would that look like? Because
Well, I'm hoping not. It adds another value here.
I don't think so.
Okay, so we'll assume that that's
Is
not
this
the case.
6.2 or is this
What's that?
still? Is this 6.2 or is this still 6.1?
It's kind of 6.2, but 6.2 does it graphically.
Okay.
So one of the like one thing that, I mean, this is very common to see on traditional classes is I say, oh, that's u, and there's v, and I want you to draw u minus u plus 2v. And you probably saw this in class. There's this thing called head to tail, maybe.
Yes. That's okay. Wait. On the um 6.2 like notes, um she talks about that on like the third page, so maybe we could do like one of those examples because those are like actual like examples on this.
You said the third page, the u plus.
On like the 6.2, like on the last couple pages.
Are you talking about the notes?
Yeah,
Okay.
because she has some that are like find the angle between you
Yes,
and
and that's
me.
coming up. Yeah, this all leads to that.
Okay. And then also like she has some dot product stuff on there. So
That's
maybe
also related to this.
okay, okay, okay.
Um, okay, let me. Yeah, I mean, sometimes I feel like I'm just going on to things that maybe aren't useful for you.
We did talk about the head to tail. I remember hearing that.
Well, let me just do this example, and then
Okay.
so like sometimes this is given, and you got a graph over here, and then we'll talk about dot products. So you grab u is, and you can say, oh well, u is 2 right and 3 up. So if you want, that's fine. It's 2 right and then 3 up. That's u. V V is you go down. I'm sorry. Well, you go right 1 and then down 2. But you have to go from this point here. You go from this point, you go uh, right 1 and then down 2. But because there's 2 of them, you have to do it again. You have to go right 1 and down 2 again. So that's your V and your V. That's 2V. Okay, and then what you're supposed to do is connect where you started with where you ended.
Okay.
So that's usually called your resultant vector. And your resultant vector, you can say, oh well, to get there I go 4 right and down 1, 4 comma minus 1, because that's how you get there.
All right. Okay.
Is that
It, it makes sense.
okay? So let's talk about dot products. I think that's really what you want to do. So you have to build up all this stuff. So again, I have to make up some vectors. You're like, u is 5 comma minus 2, and v is 3 comma minus 1. So the dot product u dot v, what it means is you actually multiply the x's and you multiply the y's. Um,
Okay. So
so
so if
it's
it's vector, you add. If it's dot product, you multiply.
that's
Right.
right, and you always get a number here.
So 15.
So 15 plus -2 times -1. So it's 15 plus 2, which is 17. So the dot product always produces a number.
Okay.
Okay. So now, like, what is, well, I'm going to ask you this. What is v dot u? So it's the same thing. It's just in reverse. So it's 3 times 5 plus -1 times -2. So it's still 15
Oh,
plus 2. It's still 17.
yeah, we get the same product. Okay.
Yes. Now, sometimes they do this. Sometimes they do this. This is like, I mean, this, I don't, sometimes they say u is a comma 4a, and v is 5 comma -3. And they say if u dot v equals, I don't know, 0, 0 is a bad number. If u dot v equals 20, what is a? Like, they ask you to go backwards. But it's still the same idea. You're finding the dot product. You're multiplying a and 5, so you get 5a plus 4a times -3, and that equals 20. So you get 5a minus 12a equals 20. So that's -7a equals 20. A equals -20 over 7.
Okay.
So are you comfortable finding the dot product? Because the next thing is based on the dot product, finding the angle between two vectors. That's something you're almost always asked to do.
Yeah. Okay. So for this last one, you just let me just. Where did you get the C from?
That's an A. Sorry, it's
Oh.
very bad handwriting.
Okay.
Oops, sorry, that wasn't supposed to do that.
5A. Oh, because it's just times one, and then yeah. Okay.
Okay, so like the more common question is to find the angle between two things. All right. So let's say let's say the angle is or I don't know, vector one is -2, -2, and that's u, and then let's say v is 2 comma 2. No, I'm sorry. -2, yes, -2, +2, and then v is 2 2, and we're supposed to find the angle between them. So there's a formula. There's a formula here for that, and you've probably seen it. This one right here, to find the angle between. Does that look familiar?
Yeah.
Okay. So the top part is finding the dot product. So what is the dot product between these two? I want you to do that for me, please.
Okay. So 0.
It's 0. Now dot product can definitely be 0. And you might think, well, that's strange. Well, let's just carry it out. What's the magnitude of u? Magnitude of u is, because we might as well work on these, it's -2 squared plus 2 squared square rooted.
So square root of 4 plus 4, so square root of 8. Which is 2 root 2.
Good. Okay. So it's the square root of 8 or 2 root 2. How about the magnitude of v?
Square root of 2 squared plus 2 squared. So same thing.
Same thing. It's 2 square root 2. So now u dot v is not normally 0, but let's just go with it for a moment. 2 root 2 over times 2 root 2. The nice thing about the bottom is the roots always seem to go away. Well, not always, I shouldn't say it that way. But this becomes 8 on the bottom. Okay, so the cosine theta equals 0 over 8. So cosine theta equals 0.
Get 8 again? Can you just run through that? 2 root 2?
Sure, I'm sorry. It's not, I didn't go run through because it's not super important, but 2 times 2 is 4. And then the square root of 2 times the square root of 2 is square root of 4, which is 2.
2.
So 4 times 2 is 8. Okay, so now this is like going back in your class. Where is the cosine of theta equals 0?
On the unit circle?
Yes, yes.
1.
It's this angle right here. What's that angle?
90.
90. That's right. So now let's look at the two vectors again. We didn't graph them, but we should have. We should have graphed them, but it's -2, 2, and then the other one was 2, 2. And you can see now that that's a right angle.
Oh, gotcha. Okay. So it's 90. That would be the angle it forms.
Yep.
Okay.
All right. Now, normally you need a calculator to do these, like because the angle isn't usually nice, but you have to be able to find these things.
So if it said like cosine theta equals like some ugly number, I don't know, like 200 something.
Well, it would be something more like this. It'd be like cosine theta equals 4 over the square root of 10.
So what would you do in that case?
You would use your calculator and you'd say, okay, I'm going to use the cosine inverse of
Okay.
4 over square root of 10.
Okay.
Do you have your calculator handy?
Oh, I can do that. Yes. And there was something like on I don't know if I'm pronouncing this right, like Euler's method or something. Is that what you use here? Or is that something completely different?
There is an Euler's thing here. It's later on, maybe in this.
I just remember her saying something about that. So, oh, should it be in radian or degree mode?
A degree.
Cosine inverse of 4 over root 10. It says error.
Oh, sorry. Do like 2 over square root of 10. I chose bad numbers.
.50.77
Yeah.
around that.
Okay. Where should we go next?
Look at the review.
Oh, the review. Let me open up the review again.
Yeah, sorry, I sent a lot of things. Just wanted to be prepared.
Yeah, just I want to make sure I get you the information you need. But okay, so I feel like we've done that. How much did you do in 6.3, if anything?
Let's see here. We did like.
There it is. Okay, so your instructor did do this. Okay, yeah. The most common question is for you to get a parametric curve and have to graph it in in this one. Let me just snip in the example that your instructor gave, and then we'll do one like it.
Okay.
So your instructor gave you this problem. You have to make a table, and then you have to graph it. Do you remember doing this, making the table and stuff?
Yeah.
Okay, so let's say I tell you that x equals 3 minus t and y equals uh, 1 plus t squared. And now, I mean, normally they don't give you the t's. They actually just, but they can do it this way. So let's say t is greater than or equal to -2.
Mhm.
So let's make a table here, and we'll fill out some of the tables. So you have to do t, x, and y. So t will start at -2. X is 5. Y is 4.
Can you just do 3 plus?
Let's go to -1. So that's 4, and then that one's 2.
Wait, wouldn't y be 5? Because it's.
Oh yeah, thank you. Yeah, it's 5. Thank you. 5. Okay. Then let's make t 0.
And then y would for the 1 would be um wouldn't be.
You're squaring this number here, so it becomes +1. 1 plus 1 is 2.
Oh yeah, you're right. Okay.
That one is 2, and then this I know. This you can do. I mean, I know you can do this. Let me just do one more point. It's 2. It's 1, and then it becomes 5 there. So now we can graph, and you're graphing the ordered pairs. So you're graphing 5, 5
How many do you have to go up to if they don't give you the t?
until you have enough to show the curve shape that they want. Then 4, 2, 3, 1. That's not correct. 3, 1, 2, 2. Let me get rid of that point there. That's no good. Okay, and then 1, 5. So this goes, and it actually has a starting point. It starts here and it goes, and you should put at least a couple arrows to indicate direction for it. Okay, so now generally after this is they ask you to find the equation the parametric, they ask you to see if you can write like y as a function of x. Did you remember doing that? Being asked to do that?
Y is a function of x.
Yeah, or x is a function of y. It'll say eliminate the parameter.
I think we saw that.
It's in here. The way you do it is you generally solve for t, one of them for t.
Okay.
So in this case, let me just snip these and I'll bring them down.
Did we some kind of form of like substitution? Is that what it is?
You can solve this one for t. So you move t over x over, t ends up being 3 minus x. And
Okay.
then you generally substitute. So you take this and plug it in over here for t. So y equals 1 plus 3 minus x squared. And you could leave it like that. You could simplify.
Okay, so if you simplified, oh, so you would have to like FOIL that.
Yes. And I mean, it depends on what your instructor wants, but it would be like 9 minus 6x plus x squared. And if we just rearrange, you get x squared minus 6x plus 10. And that's exactly what this graph looks like here.
Okay.
But like I'm much more used to the sort of mechanical problems that our instructors give you. I really like your instructor seems to err on the side of like, okay, here's not error, but like they want more conceptual questions.
Yeah, it's very much like that.
Yeah. Um, you can graph these on your calculator, but you said you have two different parts for these.
I'm not sure about this one. She hasn't said. The only part that we didn't have a calculator for in the last part was just the function analysis.
All right. So we can do another example of this. This is from the review. So Rhonda walks along, and she has her position is given by this equation here, but they tell you, they say, oh, by the way, your x position is modeled by this, and your y position is this. So we'll ignore this stuff for a moment. We're just gonna make a table because that's a critical skill here. T, x, and y. Now you gotta be. This is where because you have cosine, you can't just choose like whatever you want. You have to choose values that work really well in cosine. So the
Okay.
values that work really well in cosine are like 0, pi over 2, pi, 3 pi over 2, stuff like that.
So you would be using radians.
Yeah, it's a little bit awkward to use degrees.
Okay.
So for example, let's make t 0. X is 0 plus cosine of 0. The cosine of 0 is 1, so this becomes 1, and y is always 4. Now let's go pi over 2. So pi over 2, cosine of pi over 2, we can get that over here if we want. Cosine of pi over 2 is 0. So that's 0, but then we're adding it to pi over 2, so this becomes pi over 2, and y is 4. So now let's do it at pi. Cosine of pi is minus 1. T is pi, so this becomes pi minus 1.
And you're just basing the like cosine pi off of like the unit circle, right?
Yes, just
Okay.
knowing the unit circle.
And then 4.
Okay, so then let's do one more. So 3 pi over 2. This is just 3 pi over 2, and then These are 4. So if we were to graph these, if we were to graph, this is where it's a little, this is where it's get weird because you're like, wait, these don't look right. The y value is always 4,
Uh-huh.
but x, let's left the point, first point, 1 comma 4. Great. Okay. Where is pi over 2? Well, it's a little bit more than, it's like 3.14 divided by 2, so it's 1.57, so it's right there. And but it's still 4. And then where is
Wait, so
pi?
there's
Go ahead.
no curve then. How is that a curve?
Ask your question one more time.
There's not going to be a curve then because if y is the same, it's all going to be like in a straight line.
Yeah, it's just here. Yeah. So like it doesn't matter what number it is. Now this what's interesting is like pi minus 1 is over here. 3 pi over 2 is over here. So it looks like this thing just goes to the right,
Yeah.
right? So that's I don't know, it's a little weird, but that's what it is.
Okay.
Now part B, we're going to borrow from part A, but part B, part B has a little bit different here. So I'm going to grab this table. Okay, so what's different here is that y is no longer the same number. It's minus t, so it's 0, minus pi over 2, minus pi, minus 3 pi over 2. So now let's see what this one looks like when we graph it. So the first point is now at 1, 0. Then you go pi over 2, which is a little bit to the right, and you go down minus pi over 2, which is about there. Pi minus 1 is about 2-ish, 2.1, but then it's minus pi.
Hmm.
Sorry, this thing isn't graphing well. And then 3 pi over 2, so you keep going out to the right, it's down minus 3 pi over 2, which is, I don't know, it's further down. So it's sort of, it's doing this thing.
Okay. And then you just put the arrows for like.
In the direction. I mean, you can put as many as you want. I mean, I mean, if I were a student again, I'd probably put that many, but you really only need one. But you can satisfy your teacher by
Okay.
giving her what she wants. So that's, I mean, that's like a critical skill mechanically. Now I'm trying to think of all the questions that you could be asked here. Um, so, like, I don't know, this is very conceptual, but like, let's say x equals cosine t and y equals sine t, and I tell you that t goes from 0 to 2 pi. Do you have any idea what this looks like?
Uh, well, the graph of sine goes through like, oh,
This is the unit circle parameterized.
oh, okay.
Now it has a direction, which is counterclockwise. Okay, so this is like one of those like, well, I don't know, maybe she'll throw this in here. This is kind of a thing that's very much like what you're doing. Um, do you have any idea how you can make this go the other direction um, instead of make it go counterclockwise? How to make it go clockwise?
Put a negative?
So negative what? The cosine, sine, what would you do?
Both? I don't know. I'm just guessing.
So so minus cosine t um, minus sine t. So what that would do is if you're here, it would put you down here. Would you agree with that?
Yeah.
Okay. And then instead of being here, it would be down here. So yes, that does it. That
Oh,
makes it go the other way.
cool.
Let's say you only wanted, let's go back to this top one. Let's say you only wanted to go from the first quadrant. Let's say you only wanted to be in the first and the second quadrant. What would t go up to? So
Pi
I only want the top half here.
pi over two. No, no. Pi.
Pi. Okay. Let's say I only wanted the bottom half.
Pi to 2 pi?
Okay. What if you went minus pi to 0? What would that look like?
Minus pi 0 would be.
So it would actually be this bottom half here.
Oh yeah, because 0 and 2 pi are like at the same place, right?
Yes, yes. So these are very conceptual things we're starting to talk about. No idea what you could see, but they're definitely there.
Okay.
All right. One thing we did not talk about that was I saw earlier is I could give you a vector. I could tell you that u, sorry, not u. I could tell you that u is equal to 5 comma negative 5 negative 12, and I could ask you for the magnitude of u times the magnitude of u. That would be totally reasonable. So what is the magnitude of u? Can you find that for me?
So it's the square root of the -5 squared plus 12 squared. Nine, 6. Square root of 169, which is
13.
okay.
So 13 times 13, so it equals 169. So the shortcut here for this, because that's the number you just saw there, the shortcut is the magnitude of u times the magnitude of u equals a squared plus b squared. And this is a and this is b.
Oh, wow, that's
So
nice.
if I tell you that v equals 9 comma 40, negative 9 positive 4, doesn't really matter. And I say, what's the magnitude of v times the magnitude of v? You can say, oh, it's minus 9 squared plus 40 squared. And 16 ends up being like 1681.
Okay. That makes sense.
Okay, we've got a couple minutes left here. Let's talk about, this is a classic question you get in physics. And you may get it here. You've been driving for a while here.
Mhm.
Which does your speedometer in your car measure? Does it measure magnitude or direction, or both?
Oh, that's a good question.
Okay, so I'm gonna help you answer that. Okay, so
Oh, well, speed.
you go down the road this way, and it says 40 miles per hour. Then you turn around and go back home, and it says 40 miles per hour.
So speed.
It gives you
Well, I guess it's speed per hour, like
yeah,
per.
and that's what it is. Your car is giving you the magnitude of it. It doesn't tell you, oh, you're going minus 40 because you're going uh, east,
Right.
or it's 40 because you're going west. Your car always gives you magnitude, just the overall like number. What is it?
Okay.
Okay. Um, so the direction matters in some cases. Like um, if you were trying to explain to somebody how to get to you, you're um, you're there and your friend is there. If you told them to go 40, but you didn't tell them which way, they could go any of these ways. Do you
Right.
agree?
Yes.
So, but you need to say, well, go 40, but go 40 in that direction to get to me.
Uh-huh.
Go, go east that far and south that far.
Right. Okay.
All right. There's so much here in this, and it looks like it's 2 chapters. Like it looks like chapter 9 is something different. Um,
Yeah, and it's not the full like chapter, it's like, parts of it.
I'll just recommend that you if we're doing another lesson for the exam, just to try to go through this a little bit more, so you've got um,
Yeah, I haven't even started this reading packet,
it,
so
it, I do believe that the stuff we did tonight is more difficult than sequences, but if sequences are unclear, we can absolutely go through them and make it clear.
yeah. Okay. That sounds good. And
All
I'll
right.
just as much then as I
So
can.
I'll see you Wednesday. Just use the same booking email, and thanks again for scheduling. I'll see you next time.
Okay, perfect. Thank you.
Thank you. Bye now.